Hi students, it's Mrs. Gifford here, and today we're going to talk about lesson 2.2, logic. So after this lesson, you will be able to determine the truth values for negations, conjunctions, disjunctions, and represent them using a Venn diagram. So let's get started. So a bunch of vocabulary as seems to be par for the course for this book. So the first thing is that when you see the word statement, it's just a sentence that's either true or false, which is no different than any other statement we talk about. Then we have truth value. It's the value of a sentence is either true or false. Negation is the opposite meaning as well as the opposite truth. So here's an example. If you have this statement P, a rectangle is a quadrilateral, that truth value is true. And this little symbol, this is called a tilde. This means not P. And it says a rectangle is not a quadrilateral, so that truth value is false. Continuing with our vocabulary, a compound statement is two or more statements joined by and or. And we have a conjunction, and it's a compound statement using the word and, or you might use this little symbol, or you might see this upside down V symbol like a caret. Both statements must be true in order for a conjunction to be true, because you're using the word and. And then a disjunction is a compound statement using the word or you might see this upside down V. And in this case, only one of them has to be true because we're using the or. So the big thing to remember, conjunction, both must be true. Disjunction, only one has to be true. So let's take a look at some examples. So we're going to use these statements to write a compound statement for this conjunction down here in number 1. We're going to write a statement for not P and not R. As I said on the previous one, you might see it written with the tilde, the upside down V, and a tilde with an R to represent not P and not R. So the directions are to write a statement, write a compound statement, find its truth value, and then explain why we're thinking what we're thinking. So in this case, based on what we have here with example number 1, going off of this triangle, it says not P and not R. Well, if P is the figure is a triangle, because we're looking at not P, we would say the figure is not a triangle, and the figure doesn't have 3 acute angles. Okay, and again, that's because R says it does have 3 angles, so we want the one that's not. So in this case, the truth value is false. Okay, and it's false again because both statements are not true. In order for this to be a true statement, both have to be true. That's because we're using the and not the or. Okay, example 2. Same thing. We're going to write a compound statement and find its truth value and then explain what we're doing. So again, we've got this statement Q, upside down V means or not R. And in this case, so our statement is Q, so we're going to use exactly what we see here. January has only 30 days, and then not R. If R is January is the first day of the new year, then we say January is not the first day of the new year. That's where we change it. In this case, in this case, both statements are false. So again, this one is also false because January actually has 31 days. Okay? All right, so let's add this into your sheet where you're writing all this stuff down on, tracking all of these concept summaries. So the next thing, this is just actually combining what we just talked about in a table. So negations, conjunctions, and disjunctions. The big thing to remember is with a conjunction, both statements have to be true. Okay, both have to be true. because we're using the word and then disjunction is only one has to be true because we're using the word or. We can create truth tables to help us kind of track the truths and false in regards to the truth values of them. So here's examples of negations, conjunctions, and disjunctions. And notice the only one in the conjunction that's true is this first one because both statements are true. Okay, so let's look at example 3. We're going to make this a truth table for this particular statement, not P and not Q. Now remember, this has to be true for both. And why is that? That's because we've got the and here. So from here, we know that we can say P is true, true, false, or false. Q can be true, false, true, false. Here, all I'm doing is making the different combinations of what can happen with the P and the Q. So then if we go to not P, so if we said P is true, then we say false, false, true, true. And not Q would be the opposite of what we put in the Q column. So then from here, okay, so once we have that not Q column filled in, then we want to fill in the very last column. Now remember, both statements need to be true. So now we're going to focus on these two columns because we are making the truth table for the not P and not Q column. So in this case, both of them are false, so this is false. One is true, one is false, one is true, one is false. And the very last one is true. And again, that's because both statements here are true. So creating a truth table to help you figure out which values would make a true or a false statement. All right, last thing to talk about is a Venn diagram. And so just as a quick reminder, a Venn diagram is used to compare two items or groups. In the example that we're going to do shortly, we're going to compare the junior and senior class. As a reminder, the stuff that's in the middle here is where they overlap or true for both of whatever it is that you're comparing. The ones here on the left-hand side, anything that's over here is true only for this one. And, excuse me, over here on this right-hand side, this is true only for this one. Okay, so let's take a look at our last example. So it talks about the number of graduates last year who did not go to the junior or the senior prom. So as we're looking at this, 85 students didn't go to the junior prom. 25 students didn't go to the senior prom, and 123 students didn't go to junior and senior prom. Oops, sorry about that. So, my apologies. This is not that they didn't, this is that they did. So 85 went to their prom, their junior prom, 25 went to senior, 123 went to both, and then 37 would be where none of them went to. So let's take a look at the questions. First of all, letter A says how many graduates attended their senior but not their junior prom. So that's the group where it's only the senior group. So in this case, as I just said, this is number 25. Okay, because it's the kids only in that senior group. Letter B says how many graduates attended their junior and senior prom. So this is where you're looking for the category for both. And that is 123. And again, that's where you're looking for the overlap. Letter C, how many graduates did not attend either of their proms? And that's this one outside here all by itself, because the Venn diagram is talking about which proms they did go to. And then the last one is how many students graduated last year. So what do we have to do? We have to actually add all 4 of these numbers up in order to figure out what the whole group is that we're talking about. And when we do that, 85 plus 123 plus 25 plus 37, that's 8, gets us a total of 270. So the big thing again with Venn diagrams, look to see where they overlap and what's specific about each group. And then with the truth values, making sure we're paying attention to the truth and the false values. So there you have it, folks.